someone like some lady that probably does ceramics, and her husband does 3D printing, and it's like for Czechia. So there's like, yeah, so there's like a whole map here of places around Czechia now already. Like the map is not moving properly now. They use OpenStreetMap, so it's probably some buggy things, but anyhow.
Hello, everyone. We are about to start, so I would like to welcome you on our first talk at this stage. Thank you all so much for coming. On behalf of KCD, I would like to welcome on the stage Tobias Kässer and Yury Tsarev, who will deliver an excellent talk about AFK infrastructure and Ralph loops meet Crossplane. So without further ado, I will hand it over to Tobias and Yury. Thank you.
Thank you so much. Good morning, everyone. So my name is Tobias. I'm here with Yury. We're both working for Upbound, the company behind Crossplane. And today is supposed to be a little bit of a funny talk. So let me get my... Who knows this guy? Only 2 people know this guy? Okay, better. That's Ralph Wiggum, or I think an AI illustration of it. Before I started with Ralph, when I started using ChatGPT when it became viable, and then went to Claude, and I saw what it can do, like, I put it at a problem. It was digging through logs, stepping between cube contexts, figuring out the problem, pointing out the line. I checked, the fix looked good, I tried, worked, and I was not only impressed, but I was also depressed, kind of a little bit scared about my future, because I was like, for all of these years, I was honing all this knowledge, and now with a simple prompt, it can just do all that. And it made me feel kind of sad in some way, until there was a video I watched about context engineering, and there was an article mentioned about Ralph Wiggum as a software engineer, autonomous coding. And I was like, okay, let's find this and check it out. So in there, it was talk about like how to build software without supervising it, and I was truly fascinated by the idea. It goes back to Geoffrey Huntley. Who knows Geoffrey Huntley? You should check him out. It's very good that you don't know, otherwise I would be just repeating stuff, I think. So the main idea behind it is, if you can do single tasks with Coding Agent, right? But what about like a whole project? Just kick it off, let it go, and see what happens. And it's exactly what he did. Like he came up with this idea of let's build a compiler from scratch. I don't know what a compiler is. Like, I mean, I know what it does, but I don't know how to build a compiler. Let's just Claude build a compiler. And that's what he did. Like, he pretty much said, like, oh, I want to build Cursed, an esoteric programming language based on Gen Z slang. Just like some crazy thing, but it should be like really native and build its own standard lib with written in the same language. And he succeeded with it, so I guess you best check it out yourself, and it's a really funny thing. And yeah, how does it look like? Well, at the end of the day, it's nothing more than just a while loop. So you give it a prompt, you can pretty much check it out on his website, what's the actual prompt behind this language. It says nothing more like you plan with, like, I think he said, plan with 50 agents and make this implementation plan. And what the agent then does is it like picks the next task, and then the agent decides what's the next task on the list, and works on it until it's done, and then it exits, and then we start the same again. So why are we doing this? So unfortunately, context is limited, and the more context you accumulate, the dumber the model gets. That's nowadays not as bad as it was when this whole technique was invented, but it's still a problem, and context compaction is lossy. So every time you compact, you lose some context of what you're actually building. So the goal here is to actually look at the context itself like your input to a function or something, and you want to deterministically allocate that context array every time as fresh as you can, so that when you're building your task, you can say stuff like, first read the specs and then write my task. In this way, you're putting the model sort of on rails, and it's, on the one hand, you might think a little bit wasteful, because every time you work on a new task, you need to throw away the whole context window, but in fact, that's what made his technique work after all. So when I was reading this article, I was thinking, well, we have this case where we want to convert stuff from Terraform to Crossplane, for example, and Terraform modules are so well maintained, they contain a lot of logic, and at the end of the day, except for these weird quirks, they're pretty much just plumbing, right? There's a lot of testing involved, but at the end of the day, I just want to take user API input values and want to transform them to managed resources. So how do we do that? So in order to make this stuff work, the agent or the LLM needs to be able to observe what it's doing, right? If I just let you write code and you have like no compiler, no tests, nothing, you just like your only chance is to look at it and reason about it if it's right or wrong. I'm pretty sure most of us would also fail in this task. So that's why with the modern crossplane functions, our choice here was KCL. You can actually use a strictly typed language. So if the model makes a mistake, it can catch that very quickly. It also has composition in E2E tests. So that was actually one of the more challenging parts, to get the model to understand how to properly work with our infrastructure and run E2E tests. But at the end of the day, that's kind of what did the trick. So we try to prepare a little bit of a demo. It's challenging because like a Ralph loop is not something you kick off and you get feedback in 5 minutes, right? It's something which runs for a rather long amount of time. And before we dive into that, I prepared this little slide. And I put a camp in front of the fire for a reason, because as funny as this all is, like we're actually burning real money, and the point is not to expect that the model just figures out everything automatically by itself. The idea is that we actually need to watch what it's doing, and it's a very long-running process. Joffrey plays DJ while he's doing that. I've seen other people play music while they watch their Ralph loops. And Yury, please kick us off with the demo so we can show how it actually looks in practice.
All right, let's burn some tokens live. I apologize, I will have to be in sitting mode given the setup. So, is it visible? All good? All right, so the idea here is that we are going to try to migrate the existing Terraform model to a crossplane configuration. If you're familiar with the topic, usually it takes some effort, right? So you need to understand the logic, you need to write some code, and we are going to do nothing and just watch Ralph doing the stuff. So the first step is to create empty dir. As simple as that, and I already know as a creator of these migrations that I want to migrate some DynamicDB, right? Doesn't matter. That's what we'll use for the initial state. I'm executing Claude, trusting this folder as usual. And I'm going to use a special init project skill that was created by Tobias that is targeted to initialize this and create the initial setup for Ralph loop. I'm going to trigger it, and it starts to iterate on the project. And notice that the directory was totally empty, right? So the first thing it will try to do is to figure out if the existing model is already resides somewhere on Terraform registry, right? So as you can see, the directory is empty, and it's going to find existing model and ask us questions. Is it good? Oh yeah, thank you, appreciate it. Yeah. Am I audible better? Yeah, thank you. Thank you, Andrei. All right. Now we have this nice interactive setup, and Claude asks us what we're about to do. So, okay, drop-in replacement for existing Terraform model. That sounds about right. API group, I will use upbound. Providers, I will mark them all. Sounds pretty reasonable. Composition. KCL, main branch, recommended. Yeah, so like as you can see, it gives us options, right, including Python one, so it knows how to build stuff as we have associated skills. I will go with KCL by default for this one. And yeah, the goal is to create the configuration, Crossplane configuration as alternative to the model. The API group involved official AWS providers, and implementation for the composition logic is going to be KCL. So that's what Ralph is going to do, is migrating from Terraform HCL to Crossplane-based abstraction using the KCL for the composition logic. So we initializing that stuff is going to create a roadmap and associated task, right? So to fulfill the goal. And we'll wait a little bit while it's creating the actual skeleton for the project.
So the idea was that usually when you run this Ralph loops, you already start with like a task list, which you plan up front. I thought it would be nice to have some little wizard which guides you through all the steps. So at the end of the day, you just say like, yes, looks good, and then you kick off the loop, and that's what Yury is just working us through. It creates a Claude MD now. It's just that it knows like what it's actually building and how we're testing it.
Yeah, as you can see, it's already have a pretty good plan, right? TDD cycle, test-driven development for infra. So it looks promising. What I'm going to do next, I will ask it to skip end-to-end test. Skip end-to-end test to make implementation faster, something like that. Just, you know, to demonstrate that it can modify the plan, and also it will enable us to go through in a little bit like live mode on the Claude MD structure instead of browsing it, but actually see the diff. So as you can see, it can control its own plan. It excluded end-to-end tests, and but we are leaving the composition local test, right? So we still going to have a pretty powerful implementation. We will just leave end-to-end testing to human in this specific situation. All right, it's keeping the stuff, so it does the proper job for us in a case of planning. Yeah, it removes the tip of the testing pyramid. That looks nice. So now it's like, you know, just enough testing pyramid, and pretty soon we will be able to proceed with an actual Ralph loop execution. Yeah, this also explicit end-to-end test skip mentioning, but again, we are looking, we are still TDD, we are doing local composition testing, evaluating the cross-plane desired state in isolated manner. And now, now we can actually execute Ralph. You have any comments on that stage?
No, all good. Time to burn some tokens, for real this time.
Yeah. Yeah, so I will use this magic command for this while true that was on the slides. I can exit the current Claude session, and and use the magic command. What the magic command does, it's while true loop, right, in a shell, using cloud to execute this prompt, ATRM, iterate. What ATRM stands for?
It was like autonomous Terraform replacement module, for lack of a better abbreviation or name.
Yeah, so it's our like a command and associated skill for the migration, and it's going to output a JSON stream, and we will use some repo mirror visualizer just to observe what the loop is doing in a totally passive mode, right?
Yeah, it will just look stupid without this command. To be honest, I only know that it visualizes properly, so it gives you the tool calls and a little bit of the beginning of the prompt. Without it, we would just see like a bunch of JSON, which would be really hard to follow.
Right. So now token burning starts.
Starts already with rate limit event.
Yeah, that's standard, yeah. And so, it effectively going to iterate over the plan, evaluate roadmap, right? So maybe it's a good chance to show the roadmap. I will switch to another terminal. This is bit other project. Okay.
So we're now going to show how it looks when it already ran for a while, right?
Yeah. So now it's still it's only Cloud MD at this moment. It will create a roadmap later on, but we don't know when. So what do you think if we switch to the ready project, right? So now like what is going to happen? We don't know when it will appear, and we don't have time to wait for it, right? But we already run this Ralph loop for the same configuration to shows you the final artifact for the same Terraform model. And it was executed for a couple of days. So it's really like a really long-term end loop. You can just leave it around in Tmax as I did on some box, right? And then check out the associated work later on. So first thing first, we have this ready model. I just double check if it did in the current one anything. Yeah, so it's already started in this current one, some structure, but no, not ready yet. And that's expected. Now we have this something that was already generated. So it's already migrated the Terraform model to pure Crossplane abstraction here. So it has a function, logic that looks reasonable. It has a bunch of tests, and how it reached this level, right? So it already looks like something pretty good. So we have this roadmap that was generated out of the Ralph loop as well. The roadmap is fully or partially fulfilled. And that's how, Tobias, correct me if I'm wrong, whenever the agents can break the loop, and you can revive the loop anytime, and it will pick up the tasks. And so this loop is kind of invincible for interruption. You can always revive it anytime, so you don't have to rely on the same single session. If you look at the Git log, and it commits to Git on every task completion. If you look at that on the last piece of the diff, you will see how it checkmarked the associated pieces of implementation. So checked all the input variables, checked the resources, outputs, covered them with tests. That's pretty, looks really promising. And again, like this test suite looks really rich. It's probably the most comprehensive test suite I ever seen in a bound Crossplane project. So we can run that stuff and see if the tests are green, if Ralph and Cloud actually did a good job, at least in the local composition test automation, and get some confidence out of the thing, right?
How long did you run it? Was 2 days? 3 days?
Yeah, it was 2.5 days, I guess, till the full completion. Yeah, we actually can check. I think I have it in a first terminal. I have this complete state, but let's wait for the tests first and see hopefully nice green result.
It's local test, right? Should pass. Nothing changed.
Yeah, so like it generated pretty like a reasonable fine-grained test suite for many many scenarios of the composition logic. So just manually achieving this test suite level probably like will require some effort. So at this part, I enjoy the Ralph loop.
So maybe worth mentioning that we're running like up composition tests.
Yeah.
So it's pretty much our version of a unit test where you can just do assertions like, does this property have this value, and do we have 5 times the value here, and stuff like that.
Yeah, behind the scenes it's a crossplane render, right, with a desired composed map stream, and with this automated test framework you can evaluate this desired stream locally. So that's what it does, and we have a green test suite. And for the actual completion, like after 2.5 days, if you check that thing, that's the final stage. So it's like it was the last loop of the while loop, right? So it's completed and created whole thing, implementation highlights, and yeah, it was iterating for again more than 2 days. But partially why it took so long because it was token maxing, like rate limiting pretty frequently in my subscription. Whenever the window was enabled again for the token consumption, it did proceed right for the next step. So it's also a nice way to kind of not necessarily overpay to Anthropic, right? But like let it live and it will consume the tokens whenever they are available. So I think that's it for the demo. We have a pretty reliable implementation with a super rich test suite, and as you can see, we can like play with it and apply it to different areas, right? So in this case, it was a specific crossplane implementation, a set of skill, but the pattern is out there. Obviously, be reasonably skeptical about this stuff and double test the end result. So in this case, for crossplane configuration, if you want to roll out this to the customers, for example, we will definitely do a human-based quality check first, right? Still, but we have a very good foundation to do so, and we really spent a minimal human effort for the generation of the core of the abstraction.
Thank you.
Back to you, Tobias.
The slides, please.
Oh yeah, slides might be useful.
Thank you again. Okay, let's quickly try to digest what just happened. So like the init project skill, it's pretty much just meant to streamline the whole process. Like in a classic Ralph loop, you would start with this task list. So all we really do is we collect information from the user, like which Terraform module you want to replace, and we put that information together with the instructions, how this project is to be tested and to be run into AgentMD or CloudMD. It's like pretty much you can use it interchangeably, and yeah, usually we would also include E2E tests and run it all on an isolated box, give it credentials for a dedicated space, and where it can do E2E tests. Afterwards, when we do this iterate, the first thing which will happen is it will check if there's specification already. Because as I said at the beginning, like it all comes a little bit from spec-driven development, because you don't want to send your model just like, hey, build stuff. It should really, in the best case, know what it's building. And so whenever you kick it off, it checks if there's a spec already, and if not, it actually pulls the Terraform module or finds it on your local disk if you point it to the folder, and it will go through all the tests and all the documentation and try to extract all like if-else cases and whatnot and create a formal document with the API. Then after the spec is done, we again come with a fresh context window and build a roadmap out of it. So it's pretty much just a phased implementation plan. So it would say like first build this resource, then that resource. It has acceptance criteria, and it pretty much is like the roadmap of the project as a whole. So that's what Ralph then uses to check off when it's done, and which will also determine if we're done at the very end. And yeah, iterate pretty much just glues it all together. So you would run one runtime in it, and then in the second step, like Yury showed us earlier on stage, you would just like let it run in a loop. And it goes through all the phases, and usually it's gonna end up just like pick next element and run forever until it's done or you're out of tokens. There's an additional command which I used to run after everything was finished, because like we already said, you don't really want to trust it. And so I came up with this validate command, which the idea was it deploys the Terraform code, it deploys the Crossplane code, and then the LLM would actually check if on the cloud side everything is the same and tries to manipulate all the parameters which it can change and see if they change in the same way on both sides. So the result of my first experiment, was this year at Christmas when I was traveling to Prague, visiting my friend Yury. I was sitting in the train, kicking off that experiment, and the idea was to tackle AWS VPC module, because it's one of the probably the most used module out there. And I was very skeptical at the middle, because like I was running it for 11 days with a little bit of an on-off in between. There's 30K lines of code and really compressed test suite. And I said earlier, it's not meant to be you just run it and you expect to get like 100% working solution which is super polished or whatever. The idea is more like you save the time by constantly being in the middle of the loop and sitting outside of the loop. And the result, after I really just went through with it, was truly impressive, to be honest. Like, I pointed it, of course, at our docs, at our reference configurations, so it has a good chance of building something solid. And I think it actually built something solid. And for the cases I tested, also with the validate skill, looked all good. So what now? First of all, there's a lot of problems with this we didn't talk about. In order to make this properly work, in the best case, you run this on an isolated box. Like, you need to restrict it as much as you can, because only if you give the model full permissions, only then it can search the web. Like, is there some GitHub issue? And did some other person have the same problem as well? Fetch some docs. There might be some packages which might be, not within a good intention, I say. There might be some prompt injection, which some people try. I mean, the internet is a wild place, right? And you point an LLM at it and say, like, build me some software. What could potentially go wrong, right? It's not cheap. Like, I'm not lying. Like, you definitely, like, when I built the AWS VPC thing, like, I had a Cloud Max subscription, and it was pretty much maxed out for the whole time. And on top of that, the software you build is no longer the only artifact. It's one artifact, but you're actually building the process around it. So you build more like a software factory instead of a software. And as you saw, it's not a quick and easy process, right? So like, what if you figure that something is wrong with your process? What do you do? Like, in fact, I'm experimenting with this stuff right now, and what I do then is I just throw everything away and start at the very beginning, because if the factory is my artifact, I need to start from scratch, and so I can judge what it's actually doing. And on top of that, it feels like if we use that, everyone becoming suddenly a QA engineer, because like the focus so drastically switches to quality and raises question, how do we even reason about what the model is doing there? I guess with using more LLM, right? And yeah, on top of that, like, what even is software engineering if this stuff is viable? And to be honest, like, models only get better. Like, this stuff was done with the previous version of Sonnet, and I feel like nowadays models are even a lot stronger, and I don't think this is going to stop anytime soon. So like, where's the bottleneck in all this stuff? it's no longer just like producing code, not even testing code, I think, if it's done properly. It's more like the design, you as a human inventing stuff is the actual bottleneck. And that's, I don't know, on one hand frightening, on the other hand, it's a cool place to be in, because we're at a really new like crossroads in the whole history of software engineering, I think. And I think in the future we can think about maybe building crossplane providers. That's something I'm trying at home just a little bit for fun. We can migrate stuff, like any kind of like mechanical transformation, I think is really well fit for that stuff. And there we go. Any questions? You were first. Thank you.
Let me get you the mic, so it's also on the recording.
Sorry, did you evaluate the costs of overall work of it?
So I don't have actual numbers.
Expensive.
We had the slide with the 10, remember? No, just kidding. If you use API-based access, like Anthropic API key or whatever, right? No subscription. It's gonna hurt you. So I think that's also why Anthropic has now announced that they're gonna change the model around the pricing of non-interactive usage, most probably because of us and other people doing this stuff. But with a subscription, it's manageable, because as Yury said, you can just like leave it running, and it's going to hit the limit, and once it clears, it's just going to pick up. And then I think it's relatively cheap. But if you run it just with an API access and let it just burn, and it like the npx repo mirror command will show you at the end what the API tells you what it costs, and there we're talking in the hundreds per day.
Hundreds of dollars per day.
Yeah.
Yeah, thank you.
Welcome.
I'm getting some technical difficulties with Slido. I'm very sorry. It worked previously. Any other questions from the audience while I fix it? Thank you.
Hello. Did you try the open models to use? I mean, like DeepSeek or like, because it's important.
So I have a little bit of a project with another colleague of mine where we tried to build an NES emulator with the same strategy with Gwen. And that didn't go so well. It always gets stuck at the same point where it's just like, well, I'm running this test and it's doing an infinite loop, and then it starts just guessing some binary addresses and just like cheats its way through, and then the next loop it hits the same issue again, and that's went for days. So frontier models are unfortunately pretty apart still.
Thank you. Yeah, I see a question here.
So how far are you with the provider Crossplane?
Again?
Provider Crossplane? How far are you with that?